Okay, we'll get back to the notes here. Problem 21 is what we're on. We want to solve each equation by completing the square and then simplify the radical expression if it's necessary. Okay, so part A, I want to solve the equation x squared minus 5x equals 8, and I'm completing the square. So far we talked about factoring, and then there's the square root property. The completing the square method is another method for solving quadratics. So here's how that goes. The first thing that you want to do is you need a 1 in front of x squared. We have that. And then you want to bring the constant over to the right. We have that. So if I did not have either one of those, like in this problem right here, I'd have to get a 1 in front of x squared and then have the constant be brought over to the right. Okay, now those two things that I said, those are just the setup for completing the square. Okay, like I haven't done any completing the square yet, but now I'm all set up to do that now, okay? So how I complete the square is I take half of the number in front of x squared. I take half of the number in front of x squared. Okay, so half of negative 5 is negative 5 halves. And when I square negative 5 halves, negative 5 squared is 25. 2 squared is 4, so that'd be 25 fourths. Okay, so 25 fourths is going to be the number that I'll add to both sides there. And now the reason for doing that, because that kind of sounds like a weird thing to do, right? But the reason for doing that is because on the left, the expression will always factor, and furthermore, the factors will always be the same. That will always happen. Okay, so now I'm wanting to factor x squared minus 5x plus 25 fourths. Well, that's going to factor nicely as x minus 5 halves times x minus 5 halves. I can already know that because it's always going to be the number that you're squaring in the previous line. So in order to get this 25 fourths right here, I had to square negative 5 halves. So because that happens, I'm going to have a minus 5 halves in the two factors. That will always happen. Okay, so it's like I don't even have to think of it really. I got x minus 5 halves times x minus 5 halves, or that'd be x minus 5 halves squared, equals 8 plus 25 fourths. Well, 8 is the same as 32 over 4. So I got 32 over 4 plus 25 over 4. That'd be 57 over 4. Okay, and then now the next thing is I need to use the square root property. So when you see the methods for solving quadratics, like you'll always see the square root property mentioned before completing the square, because when you complete the square, you have to use the square root property in completing the square, right? So in order to solve this guy here, this equation, x minus 5 halves squared equals 57 fourths, I need to know the square root property. So if I take the square root of both sides, I got x minus 5 halves equals plus and minus the square root of 57 fourths. Okay, and when I take the square root of the top and bottom, the square root of 4 is 2, right? Let me go ahead and add 5 halves to both sides. That way x is all alone. So x is 5 halves plus or minus root 57 over 2. Okay, and if I write that as a single fraction, I got 5 plus or minus root 57 all over 2. Okay, now if I were to try to factor this guy, I would not be getting very far, because these nasty numbers here are part of the factors. Okay, and these are not natural numbers that I would be guessing and checking, you know, if I want to factor something. So if I'm wanting to factor something, like I'm using, you know, integer values, likely. Okay, I'm definitely not using anything with radicals. So basically, the way that we did this problem is at this point is the only option to solve, but it's it's our best option also. Okay. Part B. So let's solve 3x squared minus 4x minus 1 equals 0 by using the completing the square method. Okay. Well, step 1 is to get a 1 in front of the x squared term. Right now it's a 3, so let's divide by 3 on both sides. Now, in getting the 1 in front of the x squared term, sometimes we create fractions. That's okay, that it has to be that we have a 1 in front of the x squared term. Okay? The next thing that we do is we bring the constant over to the right. So I'm going to add 1/3 to both sides. And now I've got x squared minus 4/3 x equal 1/3. Okay, now those two things that I did there, getting the 1 in front of the x squared and then bringing the constant over to the right, those two things are just the setup for completing the square. Like I have not done any completing the square yet. Okay, but I'm all set up to do that now. So I take half of the number in front of x squared. Half of the number in front of x squared. So half of negative 4/3 would be negative 2/3. And I need to square negative 2/3. Well, negative 2 squared is 4, and 3 squared is 9. Okay, so 4/9, that's going to be the magical number that we'll need to add to both sides here in the next line. Now again, the reason for doing that, because that sounds like a weird thing to do, but the reason for it is because the left side is always going to factor, and the factors will always be the same. Okay, so now I'm wanting to factor x squared minus 4/3 x plus 4/9. I can get the factors right away. Even though I got fractions here, so what? It's always going to be the number that I'm squaring in the previous line. So because I was squaring a negative 2/3 to get this 4/9, it's going to be x minus 2/3 times x minus 2/3, or x minus 2/3 squared. Okay, so it's like I don't really even have to think of it. Okay, x minus 2/3 squared equals 1/3. That's the same as 3/9. So I got 3/9 plus 4/9. That's 7/9. Okay, and now I'm using the square root property. So I take the square root of both sides. I get x minus 2/3 equals plus and minus the square root of 7/9. And so then if I add 2/3, x is 2/3 plus or minus the square root of 7/3. So if I write that as a single fraction now, I got 2 plus or minus root 7 all over 3. Now remember that you always have two answers whenever you're solving a quadratic. Okay, so the two numbers here would be 2 plus root 7/3, that's one answer, and then 2 minus root 7 all over 3, that's another answer. Okay, now if I were to try to factor this guy, I would not be getting very far. Okay, because these nasty numbers here are the factors, and these again are not natural numbers that I would be using when I'm guessing and checking about how to factor this. Okay, so basically, I guess what I'm saying is the way that we did this problem, that is the best way to do this problem. Okay. Problem 22. So we want to solve each equation by using the quadratic formula and then simplify the radical if it's necessary. Okay. So when I'm using the quadratic formula, I need to identify A, B, and C. So A is 3, B would be negative 5. So in order for me to identify A, B, and C, I have to make sure that I'm in the form ax squared plus bx plus c equals 0. Right now, I'm not in that form unless I subtract 5x. So A would be 3, B is negative 5, and C is 1. Which means that x is equal to the opposite of B plus or minus the square root of b squared minus 4 times a times c all over 2a. So the opposite of b, let's see, the opposite of negative 5 is 5, plus or minus the square root of b squared negative 5 squared is 25, minus 4 times a is 3, times c is 1. And this is all over 2a. 2 times 3 is 6 in the denominator. Okay, so now I got all my information plugged in using that formula, and now I'm just going to simplify that as far as possible. So 25 minus 12, that's 13, right? And so I'm looking at 5 plus or minus root 13 all over 6. Okay, that would be the exact answer. Okay, so I got two numbers here. I always have two answers when I'm solving a quadratic. They are 5 plus root 13 over 6, and then 5 minus root 13 all over 6. Okay. Part B, so let's see. I need to get all the terms on one side before I identify A, B, and C. So let's go ahead and subtract 2 from both sides. I got 3x squared minus 6x minus 2 equals 0. So A is 3, B is negative 6, and C is negative 2. X then would be the opposite of B, is the opposite of negative 6 is 6, plus or minus the square root of B squared, negative 6 squared is 36, minus 4 times A is 3, times C is negative 2, this is all over 6, over 2A is 6. Okay, so then now the numbers have been all plugged in using the quadratic formula there, and now I'm just going to simplify this guy as far as possible. So I got 36 minus a negative, that means I'm adding something to 36. 4 times 3 is 12, times 2 is 24. And if I take 36 plus 24, that gives me 60. So I'm looking at 6 plus or minus root 60 all over 6. Root 60 will break down for me. 4 times 15 is 60. And the square root of 4 is 2. So I got 6 plus or minus 2 root 15 all over 6. I can simplify this further if I factor a 2 up from these two terms up top, and I cancel it with part of the 6 down under. Okay, so let me bring a 2 out from up top. 2 times 3 is 6. Plus or minus 2 times root 15 would be 2 root 15. And this is all over 6. 2 over 6 is 1/3, right? So my answer is going to be 3 plus or minus root 15 all over 3. Okay, now what I cannot do, and some students are going to do this probably, is I can't cancel out the 3's there. I can't cancel out the 3's because I'm adding and subtracting root 15 up top. It'd be different if I'm multiplying. Right? If I'm multiplying, then I can cancel the 3's, but I can't cancel the 3's. In other words, this guy here that we see, this is as simplified as we can get it. Okay, like so sometimes I see like students will get to this point here, and then they, for whatever strange reason, cancel out the 3's, and then they got a wrong answer. Don't do that. Don't do that, okay? So now, using the quadratic formula here, that's the best way to do the problem, because neither one of these equations we're going to factor nicely. Okay? So, 5 plus or minus root 13 over 6, that'd be the two factors. Those are not natural numbers, that I'd be guessing and checking. And over here, the two answers are 3 plus or minus root 15 all over 3. Okay, again, those are not natural numbers that I would be using to guess and check my answer. So the way that we did the problem, that's the best way to do the problem. Okay, the quadratic formula comes directly from completing the square. So what somebody has done for us is they've made life way easier than it could be, because now I don't need to complete the square. Okay, completing the square is kind of a long, tedious method, and one little slip up and there goes the problem, right? So it's going to be easier for me to just use the formula. The quadratic formula is the simplified version of completing the square. So what somebody has done is they've taken any quadratic equation, ax squared plus bx plus c equals 0, and they've used the completing the square method on that. So they get a 1 in front of x squared. Then they bring the constant over to the other side. They take half of the number in front of x squared, right? They go through that procedure. And what they get is the quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, we definitely know that formula, okay? We're going to be using that a lot coming up here, okay? All right, we'll go ahead and stop the video at this spot, and I'll pick up with problem 23 in the next video.